It is. 1 over infinity is 0. That's something you guys like have in your head. 1 over infinity, 1 over any large number. Like the larger the number gets, like 1 over 2, right? This is equal to 0.5. The larger the denominator gets, 1 over 4, for example, this equal to what? 0.25. So do you see how this number is getting smaller as the denominator gets bigger? That's why 1 over infinity is equal to 0. So because that's true, now we're asked, does it alternate? Does it alternate? No. Alternating means that it has like -1 to like the n, or like n minus 1. But pretty much when you see -1, you know it alternates. Is it a p-series, geometric, or telescopic? This is a p-series. It's a special p-series. It's 1 over n. Like the p-series you guys are used to is like 1 over like n to the third, or like 1 over n to the 1/2, right? If it's 1 over n to the 1/2, it diverges. If the p-series is greater than 1, it converges. But if the exponent is equal to 1, it's called a harmonic series, and it diverges. So then we can stop right here, and we can just conclude that it diverges for number 1. Number 2. This one looks a little more complicated, but with negative exponents, I just like to like treat it like a fraction. That's what the negative exponent does to this one.
I finally did it.
So the first question is, does, when we apply the nth term test, does it equal 0?
12 questions.
So when we plug in infinity into here, does it equal 0? It does. If you remember from Tuesday when I taught you guys about FEPL, FEPL is an acronym that tells you like which part like of the function grows faster, like which one goes towards infinity first. Like if you had a race between the numerator and the denominator, which one would reach infinity first? So we see that in FEPL, our denominator is the e exponential, and our numerator is technically the p, a polynomial. So that means the bottom goes bigger. Does that make sense for everybody? So that means this, because the bottom goes bigger, this goes to infinity, which means it goes to 0. Which means the nth term test makes it go to 0. So then, following along this flowchart, does it alternate? No. So then, is it p-series, geometric, or telescoping? It's neither one of those. So then, because it's not either one of those, or because it's not one of those, we apply either root test, integral test, ratio test, or LCT or DCT. Now this is probably one of the tricky parts, because you have to like recognize which one to use. And with more practice, like you guys will recognize it, but for this one, you would apply the integral test. I'm not going to do it, but like once you start getting the hang of these problems, you'll like recognize that, oh, you need to use the integral test for the problem. You need to use the ratio test. For this one, you'll use the integral test because you have a negative exponent, which makes plugging in infinity like a lot easier to work with. Number 3. Does the limit as n approaches infinity for number 3 equals 0? Now this one's a little trickier, but but the answer is it does go to 0, because if we distribute this n, right, this is technically 1 to the n divided by 2 to the n, and the denominator is bigger, right? So it does go to 0, yes. So we go take this path. Does it alternate? No, so we go here. Is it p-series, geometric, or telescopic? It's a geometric series. Geometric series are ones where it's like, there's usually like a fraction in here, like this, and it's called the r. So yes, this is a geometric series. And then for geometric series, if the r is a fraction less than 1, then it converges. If it's greater than 1, it diverges. And over here, lastly, this problem. Does the limit as n approaches infinity equal 0? And then when we evaluate limits at infinity, we look at the largest exponent, right? What's the largest exponent on the top? A lot of people would think it's 3, but it's 3 over 2, right? Because of the square root. the square root adds a 1/2 power. So there's 3 to the 1/2, or to the 3/2 power, plus n to the, you just think of it like this, 3 to the 3/2 power. Sorry, n to the 3/2 power. And the bottom is n to the 4th. Again, the bottom's bigger, so yes, the limit does go to infinity. Does it alternate? No. Is it p-series, geometric, or telescopic? Telescopic. This one's a p-series. It might be hard to tell, but if we reduce it, this is n to, or this is 1 to the n to the 5 halves. Yeah. And that's a p-series that converges. And this is pretty much it. Thank you. And have a good day.
Thank you again. Thank you.
Can I post that on YouTube?